Hi class, we are going to look how we're going to solve Fourier series. Okay, in general, your Fourier series can be written in this form of series where you have linear combinations of cosine of n functions and sine of n functions. And you notice that your a n here and your b n here is what they call the Fourier coefficient. Okay, and usually we would want to compute this. If you expand the series, so in general you start with your a naught, and then you have an, a2 up to an, multiply with cos an, of course, and then you have bn. Of course, there's no b naught here because if you are taking sine 0, will be give you 0. So you start with b1 up to bn. Okay, so this is a general form of your Fourier series. Okay. And then you can compute your respectively coefficients, a naught, okay, an and bn using this integral. And the objective would be you should be able to compute the a and bn, and then you can expand your functions here, okay, in terms of cos and sine forms. Okay, you can also expand your functions in a Fourier series of complex form because you can write down your cosine and sine functions using the Euler formula. But in this case, we focus on cos and sine forms. Okay. To solve this in particular, we are looking at period of 2 pi. So over here, if you look at the sketch, so the size of this one is pi, size of pi. So you have a functions of here fx equals to 1. And this one is fx equals to 0. So you can expand this cycle. So over here, for example, you have 3 cycles. So 1, then this one number 2, and this one number 3. Okay. So for period of 2 pi, we are going to use this specific formula. Or instead of using the figure, you can write down your functions in this form. I put this a star. Your functions is 0 from minus pi to pi, and your function is 1 from 0 to pi. So you take this part. Okay, I also did give you the period of 2 pi. So this is another versions to represent figure 5.1. Now let's just move on to compute a naught. So your a naught is 1 over pi. So this is when your functions of x equals to 0. And this is your functions of x equals to 1. This is easy, give you 0, and then you just integrate, so pi over 1 pi, so your a naught equals to 1. A naught equals to 1. Next for an, so the first term is easy, your functions of x is equals to 0. Then this again functions of x equals to 1 times cos and x. Again, you just integrate. Remember for n, integrate, you have n over here, 1 over n and x sine. So you expand. So whenever you substitute pi and 0 here, whatever n is, give you always 0. So by right, your an always 0. Okay. Next is bn. I leave the functions of 0, so I just deal with the second term. So you have a functions of x equals to 1 here, sine and x, you integrate. So sine and x, you integrate, you got minus cos and x, you have 1 over n there. So you can expand. So you have n pi and cos 0. So you have to be careful of this, you have to check. Cos 0 always give you 1, but cos n pi you have to choose specific n. So your n can start with 0, 1, 2, 3. So you can divide your n in terms of odd or even. So if you go by odd, they always give you minus 1. If you go n even, they give you plus 1. In the end, you can write down, so cos 0 here always 1, that's why you get 1. But for this case, you can apply this. So what does it mean by minus 1 up to n? So if your n is 0, you produce minus 1. If your n is 1, you produce minus 1. If your n is 3, produce minus 1. So these come back to the case of odd of n. In this case, you can rewrite your Bn in this form for even n. So n even, they always produce positive 1. So in this case, 1 minus 1. So that's why I give you 0 from here. Okay, but for this case, you have n pi, always n minus 1, n minus 1. So this is n pi minus 2. So you always have 2 over n pi. Okay, or you can just leave out like this. Your Bn, if you are confused, n pi, so you have over n minus 1. So you can choose n. So if n is 0, so you can have, well, it's weird because you don't have that. Of course, you don't have Bn equals to 0, so this is not apply. All right, doesn't work. So if your n is 1, so you have pi, n is 1, minus 1, minus 1, so you have minus 2, you have 2 over pi. And then you can choose n2. Okay, so you can just substitute. So at the end, for the case of period 2 pi, your expansions of functions in terms of Fourier series is a0 plus a1 cos x plus a2 cos 2x plus a3 cos 3x plus blah blah blah. And then you have b1 sine x plus b2 sine 2x plus blah blah blah. Okay, so now you see there's no an is equals to 0, so this whatever n is always give you 0, but your a0 is equals to 1 and your b1 is equals to, you don't have b0, so your b1 is 2 pi. How about your bn, b2, but only odd survive. Okay, so b3 2 over 3 pi, b5 2 over 5 pi. Okay, where do I get this? It's this part, it's from here. Okay, then you can expand. So 1 over 2, you don't have anything on an, but you have pi sine x plus plus you got only b3, so you have 3 pi sine 3x plus 2 over 5 pi sine 5x and blah blah, only odd survive. So these are 3 terms. So you have first terms, second terms, 4 terms only on sine and x. So this will be your Fourier series. Series of these functions. Okay, thank you.